Hey guys, so today we are doing Newton's third law. Newton's third law is the law that states that every action will have a reaction. Okay, that's why it's also called the action-reaction law. Okay, it's not like the Newton's first law or Newton's second law. Newton's first law deals with balanced forces on one object. Newton's second law deals with unbalanced forces on one object. Whereas for Newton's third law, I'm actually talking about two different objects that are interacting with each other. So when object A exerts a force on object B, right? Object B in turn also exerts an opposite and equal force on object A. It's about two different forces, each exerting a force on one another. These two forces that the two of them exert on each other are going to be opposite and equal. All right? So distinguish Newton's third law with Newton's first law and Newton's second law. Newton's third law, we are primarily dealing with two different objects. If I only have one object, I will not be able to see the Newton's third law pair, otherwise just called the action-reaction pair. Okay, so the first level of the Newton's third law that you must remember, right, is how to identify a Newton's third law pair. Or in other words, I give you two forces, you need to be able to tell me whether it is a Newton's third law pair or it is not a Newton's third law pair. A Newton's third law pair must fulfill all four criteria. Okay, the two forces must be of the same nature. So which means if one of the force is a gravitational force, which is like, let's say, weight, okay, then the other Newton's third law pair must also be a gravitational force. Otherwise, a physical force or a tension force, for example. Okay, so they must be of the same nature. If one of them is magnetic, so magnet A attracts iron nail B. So let's see, magnet A with a north and south pole, okay, and then I got an iron nail. Okay, the iron nail feels a force, that's why it starts moving towards the magnet. At the same time, this force, right, is a magnetic force, okay. Then at the same time, right, the magnet also feels another force going towards the iron nail, which means if you hold the iron nail, you see the magnet moving towards the iron nail. This force is also magnetic. Okay, so these two forces is a Newton's third law pair. Both of them are of the same nature. Then the second one, B must be of the same magnitude and opposite direction. This is the common one. All right, so this will be quite easy to spot. Same magnitude, opposite direction. Okay, and they must be acting on two different bodies. Okay, so you see that my example here with the magnet and the iron nail, this force on the magnet, this force on the iron nail, they act on two different bodies, the magnet and the iron respectively. So this is a criteria for this situation is fulfilled. Okay, so let's consider another example that you see all the time. Let's say I have a box on a table. I have the weight of the box. I also have the normal reaction force of the box. Okay, let's go through a criteria one by one. Are they of the same nature? Okay, weight is a gravitational force. Weight exists because of gravity. The normal reaction force is a physical force. It is there because the box touches the table and the table doesn't really like that. Right? So first criteria, straight away fail already. So the normal force and the weight is not an action-reaction pair. Criteria 2, they are of the same magnitude. Yes. They are of the different opposite direction. Yes. Criteria 2, criteria 3, they fulfill. Criteria 4, they are acting on the same body. Both the normal force and the weight both act on this box. They are not acting on two different bodies. Okay. So the normal force and the weight is not an action-reaction pair. Okay, so I stress the first level of Newton's third law that you must know is to use these four criteria and to determine on your own whether the two forces given to you are they a pair or not. Okay, then we move into the second part. If I give you one force, how to identify who is the other force that is a pair with the force that I just give you. All forces must exist in pairs, right? The action-reaction, they make up one interaction. Okay, so whenever I exert a force, there must be another force somewhere else. Okay, so if let's say I have a force on this particular object, right? Okay, there must be another force on another object, I don't know which one is it. Okay, there is opposite, equal, same nature, and of course acting on another object. Okay, second part, the more difficult part of the question is to see where is this force and acting on which body. Okay, let's follow this scenario here. Okay, I have a man who is pulling at two boxes, A and B, all of them attached with a string. Okay, so if we determine all the forces on A, right, I have a lot of forces. Okay, so remember how I teach you how to determine forces on an object? Okay, first of all, draw the weight. It is the only non-contact force that you know. Okay, so weight first, the only non-contact force. Once I'm done with the only non-contact force, I move up to the contact force. It's touching the table. So let me use another color for it. Okay, it's touching the table, it's touching the string, it's touching another string. So every time it's touching another object, I most probably have another force acting on my object. And then in this case, I have two different tension, T1 and T2, and the normal force together with the weight. So there's a total of 4 forces acting on my box A. Okay, which one is a action-reaction pair? None of them are. Okay, because why? Because all 4 forces are acting on the same object. Straight away, criteria for all of them will fail already. Okay, in addition to box A, let's look at box B also. So we can draw the same force diagram for box B. Okay, again, box B has its weight, it has the normal force, the table is pushing back, and then box B is also attached to the same string, and because it's attached to a string, it feels T3. Okay, so let's look at these two, this tension and this tension. Okay, the one on top, T2 exists because of B. Okay, let me write that down so that it's clearer. Okay, T2 exists because of B and acts on A. T3 exists because of A and acts on B. Okay, then you go and check again. They are acting on different direction, they have the same magnitude, they act on different bodies, same type, both of them are tension. Yep, we have ourselves a Newton third law pair here. Okay, T2 and T3 is a Newton third law pair, otherwise known as a action-reaction pair. Okay, so now that we have identified one pair, okay, let's take a step back. I can only see that T2 and T3 is a pair only when I draw the force diagram on object B. Okay, if I don't draw object B, there is no T3, I will not be able to see the pair. So the same thing here, the 3 other forces, weight, normal force, and the tension in the string, right? All these 3, right, is not going to appear until I draw another object. Okay, and then you will ask yourself, what causes the weight, what causes the tension, or what causes the normal force here? Okay, that will help you identify the pair. All right, so next what we're going to do is to, for each of the force, identify who is the Newton third law counterpart. Okay, each force must have a Newton third law counterpart. Okay, so to help identify, we ask ourselves what caused the force in the first place. Okay, so the tension in the string one, right, is obviously caused by the man pulling at the string. So let's think about the man. All right, so imagine that you're the man tugging at the rope. How will you feel? You feel that the rope is pulling you towards the box. Okay, so this is force on man by string. Basically, every force caused by string is a tension force. Next, let's look at the normal force. Okay, the normal force is due to the floor. Okay, the box wants to go into the table, but the table doesn't want the box to go into the table, so it exerts a force on the table. So the box also exerts a force on the table. So the force on table by the box. And then because it's a Newton third law pair, you should know how it most probably looks like if I draw the table like that. It is going to be opposite and equal, and this will be my force. Now, we fall towards the surface of Earth, right? It's because Earth pulls us down towards the center of Earth. Okay? At the same time, we pull Earth towards us also. Okay? So let me repeat. What is gravity? Gravity is a phenomenon where Earth pulls us towards the center of the Earth. We, at the same time, because of Newton's third law, pull at Earth also, towards ourselves. Okay, so this force is force on Earth by box. Okay, the box attracts Earth also. It's not just Earth attract the box also attract the Earth at the same time. It's just that Earth is so massive that it is very hard to move the Earth by 1 millimeter. Okay, so much more massive as compared to any one person. Okay, that's why the force on Earth is, for most circumstances, immeasurable. It's so small that I cannot measure it. Okay, so that wraps up this small video on Newton's third law. So what are the things that you need to remember? First of all, identify a Newton's third law pair. They must fulfill all 4 criteria. Okay, if I were you, I will check for criteria 1 and criteria 4 first, because these are the 2 that usually make or break the selection process. Okay. Second part of the lesson is where I give you one force and I expect you to tell me who is the action-reaction pair. Okay. For this one, ask yourself, what are the objects cause the force on box A? Okay. So you look at all the forces on box A. T1 is because of man. The normal force is because of table. Weight is because of Earth. T2 is because of box B. So you need to kind of understand who is it because, and then if it's because of box B, I go and look for the action-reaction pair on box B.